The topic is solving equations, review of addition and multiplication properties. The objectives in this topic: use the addition property or the multiplication property to solve equations, use both properties to solve equations, and translate word phrases to mathematical expressions. So once again, statements like 5 plus 2 equals 7 are called equations. An equation is of the form expression equals expression, and we can label it as the left side of the equation, the equal sign, and the right side of the equation. If A, excuse me, if A equals B, then A plus C equals B plus C, and A minus C equals B minus C. In other words, we can add the same thing to both sides of an equation, or we can subtract both things, the same thing from both sides of an equation without changing its value. Likewise, we could multiply both sides of an equation by something or divide both sides of an equation by something and not change its value. So if A equals B, AC equals BC. A over C equals B over C. We're going to do some examples like we did before with the addition and multiplication properties, although now we're going to have the extra step of making sure there are no like terms to combine first before we use the property. Here we have x plus 6 equals 1 minus 3. On the left side of the equation, we have x plus 6. There's nothing we can do to that. On the right side of the equation, we have 1 minus 3. We can simplify that, so let's simplify the right side. 1 minus 3 is negative 2. X plus 6 equals negative 2. Now we can apply our properties of equality to get the x by itself on one side and everything else on the other. So we have x plus 6. We want to get the x by itself. We need to undo adding 6. We do that with its opposite, subtracting 6. So let's subtract 6 from both sides. X plus 6 minus 6 on the left, negative 2 minus 6 on the right. The plus 6 minus 6 cancel each other out on the left, just leaving us with x. On the right, negative 2 minus 6 is negative 8. We can check our answer in the original equation to see if we're right. Instead of x plus 6, we'll go negative 8 plus 6 equals 1 minus 3. That gives us negative 2 equals negative 2, which is true. The solution checks. The solution is negative 8. Another one, 10 equals 2m minus 4m. Let's look at the left side and let's look at the right side. Make sure there isn't anything to simplify first, that there aren't any like terms that we can combine. Looking at the left side, we have 10. Can't do anything to 10. 10 is 10. On the right side, we have 2m minus 4m. We can combine like terms. 2 of them minus 4 of them is negative 2 of them. So 2m minus 4m is negative 2m. Now we have 10 equals negative 2 times m. We need to get the m by itself. We'll undo times negative 2 with its opposite divided by negative 2. And whatever we do on one side, we have to do on the other. So both sides get divided by negative 2. On the right, the negative 2's cancel out, just leaving us with m. On the left, 10 divided by negative 2, positive divided by negative is negative. 10 divided by 2 is 5, so negative 5 equals m. That's the same as saying m equals negative 5. Remember, it doesn't matter which side of the equal sign our variable is on. If we go to check, we're going to plug -5 in for m in the original equation. So we have 10 equals 2 times -5 minus 4 times -5. 2 times -5 is -10. -4 times -5 is +20. -10 plus 20 is 10. So 10 equals 10. That's true. The solution checks. The solution is -5. Another one. Don't just jump straight to undoing division with multiplication. We have to examine both sides first to see if there's anything that simplifies. Looking at the left, -8 plus 6 is -2. We can simplify the left side and get -2. Then on the right, we need to undo dividing by 3. We do that with multiplying by 3 on both sides. 3 times -2 is -6. So -6 equals A. Plus 3 or times 3 divided by 3, those cancel each other out, just leaving us with A. If we check, take that -6, plug it in for A. -6 divided by 3 is -2. -2 equals -2 is true. The solution checks. The solution is -6. Let's kick it up a notch. -6y minus 1 plus 7y equals 17 plus 2. Here we're able to simplify each side of the equation. We can do something on the left and we can do something on the right. On the left, let's just pick up and move that 7y so that it's next to the -6y. On the right, let's do 17 plus 2 is 19. Now, -6 plus 7 is +1. That means that -6y plus 7y is +1. -6 of them plus 7 of them is 1 of them. And 1y is just y. So we have y minus 1 equals 19. This we can solve by adding 1 to both sides. To get the y by itself, we undo -1 with +1. Whatever we do on one side, we do to the other. We get 19 plus 1 is 20. Y equals 20. If you want to check that, I leave that to you. Next up, -4 minus 10 equals 4y minus 5y. Once again, we can do something to both sides of the equation. On the left, -4 minus 10 is -14. On the right, 4y minus 5y is -1y, or -y. 4 minus 5 is -1, so 4 of them minus 5 of them is -1 of them. Just minus y. Now, normally we want positive y equals. We have negative y equals. We can divide both sides by -1. And that gives us +14 equals y. In other words, the opposite of y was -14. That means y is +14. (13x) equals 4 times the quantity 3x minus 1. We can simplify the right side. We know how to multiply to get rid of parentheses. 4 times 3x is 12x. 4 times -1 is -4. That simplifies the right side to 12x minus 4. Now, we have a complication. We have x's on both sides. We can't get the x by itself until they're all on one side. What tools do we have at our disposal to get rid of a +12x? Well, we can subtract 12x from both sides. 13x minus 12x on the left. On the right, 12x minus 4 minus 12x. 13 of them minus 12 of them is one of them. So that's just x equals on the left. On the right, 12x minus 12x is 0. So we're just left with the negative 4. X equals negative 4. So that was interesting. 5y plus 2 equals 17. In order to get the y by itself, we need to get the 5y by itself. We need to get the term with the y in it by itself. We need to undo adding 2. We do that with subtracting 2. Whatever we do on one side, we do to the other, so subtract 2 from both sides. That leaves us with the 5y on the left, and on the right, 17 minus 2 is 15. Now, to get the y by itself, we need to undo multiplying by 5. We do that by dividing both sides by 5. We've just used both properties in the same equation, the one where we add and subtract and the one where we multiply and divide. This leaves us with y equals positive 3. So we can kind of get into the groove of there being a certain thing we do in every situation. Simplify both sides. If there are parentheses, we need to distribute to get rid of them. Combine like terms on the left, combine like terms on the right. Use the addition property of equality to make sure all of our x's are on one side and there's none hanging out on the other. Use the addition property to get everything where it needs to be on which side of the equation. Simplify. And then use the multiplication property to divide by whatever we need to divide by to get the x by itself. So how can we apply that here? First, simplify each side of the equation. So we can distribute that negative 4 on the left, get negative 4x minus 8. And then on the right, 2 minus 10 is negative 8. Combine like terms on the left. Negative 8 minus 60 is negative 68. Now, keep the x's on the left. Add 68 to both sides to get all the numbers on the right. In other words, to get the x by itself, we need to get the negative 4x by itself. We need to get rid of subtracting 68. We do that with its opposite, adding 68. Whatever we do to one side, we have to do to the other. A number plus its opposite on the left is 0. That just leaves us with negative 4x equals negative 8 plus 68 is positive 60. Finally, divide both sides by negative 4 to undo multiplying by negative 4. So multiply by negative 4, get rid of that by dividing by negative 4. Whatever we do on one side, we do to the other. 60 divided by negative 4 is negative 15. We're left with x is equal to negative 15. Before we finish off this topic, a quick review of our word problem words, our addition indicators, our subtraction indicators, our multiplication indicators, and our division indicators. This is not the first time we're coming across these, which must mean we're about to write phrases as algebraic expressions. We're going to use x to represent a number. So the sum of negative 3 and a number would be adding -3 and a number, adding -3 and x, -3 plus x. -5 decreased by a number. Well, if we're decreasing something by a number, we are subtracting a number from it. Starting with -5 and subtracting x. -5 minus x. C is very straightforward. 3 times a number is 3 times x, or 3x. D, a number subtracted from 83. Don't do x minus 83. If we're subtracting from 83, we're starting with 83. We're subtracting a number from that. 83 minus x. And the quotient of a number and -4, the quotient of means division. Division, the order matters. First divided by second. A number divided by -4. X divided by -4. And a note, if we have a negative on the bottom, we can write the whole thing as a negative because that is a positive x divided by a -4. And positive divided by negative is negative overall. We can write that as -x/4. Let's do some more complicated ones. Still using x to represent a number. The product of 5 and a number decreased by 25. The product of 5 and a number would be 5 times the number, 5 times x, or 5x. And then we're decreasing that by 25. We're subtracting 25. 5x minus 25. B, twice the sum of a number and 3. Twice the sum means 2 times the sum. The sum is the result of an addition problem. The sum of what? A number and 3. So x plus 3. Twice that whole thing means twice 2 times parentheses, x plus 3. Why did this one have parentheses but the last one didn't? Well, in the last one, we were taking the product and then subtracting 25 from that. Multiplication and then subtraction. Here, we're taking the sum and we're multiplying by the sum. The sum is the entire x plus 3. So the parentheses group that together, representing the sum. And then 2 times the sum is 2 times the entire x plus 3. C, the quotient of 39 and twice a number. The quotient of means divide. First divided by second. 39 divided by twice a number. 39 divided by 2x. And that is it for this primarily review, but then we did advance a little bit from where we left off last time topic.